We can now kick it off with our first talk of the day by Michael Armburst. Michael is a distinguished engineer at Databricks, and he is the creator of Delta Lake and Delta Live Tables. Michael will walk us through the Lakehouse platform and how it is the best platform for data engineering. Take it away, Michael.
Thanks, Ari. I'm really excited to be here today to talk about the Databricks Lakehouse platform. Before we get started on that, why should we even care about the Lakehouse? We've been seeing this trend for many years where these big tech companies have been causing all kinds of disruptive innovation through their use of data analytics and AI. Basically, their main competitive advantage is their ability to acquire huge amounts of data, store it, and process it so they can understand how their business is working and also predict the future. But I don't think this is actually unique to these large tech companies. And in fact, I would say in 5 years, every company is going to be defined by data, analytics, and AI. And you might ask, how is that possible? Well, let's take some examples of the data-defined enterprise and see how analytics and AI are essential to their business. One area is customer engagement. You can bring relevance and hyper-personalization to every touch point. You can predict which customers are going to churn and take action before that happens. You can also use data and AI in product development. You can understand how people are using your product and use it to decide how you're going to change that in the future. You can use it to optimize your workforce and unlock productivity through real-time insights. So people are no longer waiting for data. They just have it at their fingertips as soon as they need it. And finally, you can use it to optimize the efficiency of how your business operates and maximize productivity. When we see customers start on their data journey, they often go through this maturity curve. And we see this kind of broken into kind of two key sections. In the beginning, you're mostly looking at the past. You're trying to understand what happened. You start by just trying to take all of that data you've collected and clean it so that it's ready for consumption. Once you've got clean data, you can start building reports that analyze how things have been happening in the past. As people get more advanced, they'll start asking questions and using the data to answer ad hoc queries, and they'll start exploring it to discover new insights. Once you've got all of that mastered, though, you can start looking forward into the future. You can start asking questions like what will happen and how is the best way to respond to that. And when you get really advanced, you can finally start automating it so that those decisions are automatically made by the system with no human intervention. And so kind of in summary, what we see is there's kind of two classes here. You have business intelligence where you're looking at the past, and artificial intelligence where you're starting to model and predict the future. Now, this sounds great, but the problem here is most organizations struggle because their systems aren't able to support their goals. And the reason for this comes down to this dichotomy between the traditional data warehouse and the data lake. We have the familiar data warehouse, our traditional relational database, which is highly reliable and very efficient, and it's been used for many years to do business intelligence and SQL analytics. But then came along the data lake, and this unlocked a whole new type of data. We could now store vast amounts of raw data in the form of logs, text, audio, video, or images. And the problem is, having these two different worlds, you end up spending a lot of time copying data in between them. And this disjointed and duplicative data silos lead to problems. Additionally, these two different worlds have incompatible security and governance models. So you're spending all of your time trying to reconcile who has access to what data and who shouldn't have access to what data. And the reason you end up kind of bridging the gap between these two worlds is neither world supports all the different use cases you want. The data warehouse was great for doing business intelligence and SQL analytics, but only the data lake could do data science, ML, and low latency cases like data streaming. But we think that there's no reason to have these two disparate platforms. Instead, we propose the Lakehouse paradigm. The idea here is you have a single reliable data platform that can efficiently handle all data types, whether it's structured data or unstructured files. And the foundation for this is Delta Lake, which I'll talk about in a little bit. On top of that, you have one security and governance approach for all of your data assets that works on any cloud. And we call this Unity Catalog. And then finally, you can do all of your ML, SQL, BI, and streaming use cases on top of this platform. And these are all of your different data applications. So now we have the Data Lakehouse, one place for all of your data analytics and AI unified into a single platform. And this is something that not just Databricks has noticed. In fact, we've seen it across all of the different cloud vendors. You can see that Azure has been talking quite a bit about the Lakehouse. Google has also been talking about their open data lake. AWS has been, one of the places where the Lakehouse was born. And even traditional data warehouses like Snowflake are taking note. But one of the things you'll notice is, do these offerings really stack up, and are they a true lakehouse? And one of the key problems here is, while it's great to have open support for open formats, you really have to architect your system from the beginning in order for it to be cost effective to operate in this way. Here you see a comparison of the total cost to run a standard decision support benchmark called TPCDS on 3 terabytes of data. And so what we did was we basically took this benchmark and we tried to see how all of these different cloud data warehouses would perform when they were using open lakehouse formats. And what you can see is Databricks SQL is dramatically cheaper. While these other engines are able to operate on lakehouse formats, they aren't optimized for it. And so you end up paying for significant inefficiencies. And we wanted to drive a little bit deeper and understand exactly where was that cost coming from. And you can see it's not just running the queries. In fact, a significant part of the expense is just loading the data into the system and allowing it to do auto clustering so that you can get good performance. In Databricks, since we've kind of optimized for the lakehouse architecture from the beginning, you can see all of the steps of the data journey are dramatically more efficient and therefore dramatically cheaper for you. And it's not just benchmarks that are showing this. We've seen performance and efficiency from many of our different customers. For example, Johnson & Johnson used the lakehouse architecture to replace 35 different data sources, streamline their supply chain management, and dramatically improve their inventory predictability. And what this meant was they were able to get the data significantly faster, and they were able to cut their costs for data engineering by up to 50%. So what does it actually take to build the lakehouse? Now I want to take some time to go through some of the different layers and talk about why they're important. So at the bottom of the stack, we have Delta Lake. Delta Lake is the system that allowed us to, rather than store a bunch of Parquet files out on cloud storage, it actually took all of the nice things of cloud storage, meaning that it's very cheap to operate and incredibly elastic, so it can scale to any amount of data that you want to store in it. And it changed it from just being a dumb collection of files to a full relational table with all of the benefits that that means. So what Delta Lake brings is both data reliability and performance to your data lake. So it's designed from the beginning for high performance transactions at massive scale. It can handle, millions of partitions and millions of files. And it brings reliable table operations by bringing ACID transactions to these operations. So you no longer need to worry what happens when there's a failure. ACID will automatically take care of it for you and clean up. It was built for the beginning from streaming because we knew that low latency was becoming increasingly important. It's also the only industry standard, completely open way to do data sharing. And a key benefit here is it's completely open and community driven. So it's not owned by one single vendor, and it has inputs from many different people around the space. The community is pretty big, and this is one of I think it's key enabling parts of Delta. All of the source code is available on GitHub. Governance is managed as part of a Linux Foundation project. We talk about the public roadmap, is all available out there on the internet. And finally, we have community events and office hours where you can meet other people who are trying to solve similar problems. And what this means for you is you never need to worry about being locked in by your data format. Another key benefit of being an open ecosystem is it means that you aren't stuck using one tool for one job. You can use whatever the best tool that you prefer is at any time. So Delta Lake has always had support for Spark and Hive and some of these other kind of more traditional big data formats. But as we've expanded the project, we added support for Beam and Power BI and Kafka, and we just recently added support for Flink, Trino, and Presto. And in the near future, the ecosystem will continue to expand as we add support for Pulsar and Google's BigQuery. And one of the key parts about Delta Lake is performance. It brings a significant performance improvement, not only over just storing a bunch of Parquet files, but over many other storage formats that have recently been created. We again ran this TPCDS benchmark on Delta Lake and 2 of its other open source competitors. And what we see is Delta Lake is dramatically faster. In some cases, it's almost 2 times faster. And in other cases, it's almost 4 times faster than these other formats. And what that means is you can save a lot of money just by using Delta Lake. And on top of, now that we've kind of figured out exactly how all the data is going to be stored, now we can talk about how we're going to govern all of that data. And our answer for that is Unity Catalog. Now, before we talk about how Unity Catalog solves these problems, talk about what these problems are. So when you just had a data lake, you were basically just managing permissions on top of a big collection of files. And this is actually pretty difficult because it's incredibly coarse-grained. It means that you can't, shield individual rows or individual columns, and that kind of coarse granularity makes it very difficult. You end up creating lots of copies in order to deal with it. Another problem is the metadata about the files and the metadata about the tables was often stored in two different systems, and they can be out of sync, and it was just a lot of orchestration and management. And finally, if you have a separate data warehouse, you now have a different governance model. You need to think both about these files as well as the management of your data warehouse. And if you're getting more advanced and you start doing ML models and dashboards, you have yet another governance model to worry about. And this is why we created Unity Catalog. It's a single permission model for all assets, whether it's collections of files or Delta tables or ML dashboards and models. You can manage all of these things in a fine-grained way using standard ANSI SQL grant and revoke semantics. And this means you not only have this kind of centralized governance, but you also have centralized auditing and lineage as well, so you can understand exactly where data is coming from and how it's being used. And so to summarize, the Data Lakehouse brings all of your different data into one place, into one platform, so that you can do all of the different operations on top of it that you want. But now I'd like to focus in on one of those challenges, which is data engineering. And the reason I think this is so interesting is because many organizations struggle. They can start, getting data in and analyzing it, but as the scale increases, maintaining that infrastructure at scale becomes very complex. And what we've seen is, as a result of this complexity, a lot of data that is collected is actually just never used. It's just thrown out. And the reason for this is it's a very hard problem to do this data engineering. Data engineers spend a lot of their time on undifferentiated heavy lifting. Well, that means that they spend a lot of time hand coding data ingestion and transformations. They manage a whole bunch of scalable infrastructure. They have to think about orchestration and managing their production workloads. And again, as you have all of these different tools, you end up having incompatible governance models that need to be managed. And this is why we think the best data engineering platform is a lakehouse. Let me walk you through that. So the idea here is we're going to be able to connect to all of those different open sources that the Lakehouse enables. We'll be able to adjust, transform, and organize, and then that will allow us to do streaming analytics, BI and reporting, and data science and ML. And we have two kind of key tools for doing this: Delta Live Tables, which is the best way to do ETL. That means whether you're ingesting data using our tools like autoloader and copy into, or transforming it until it's ready for consumption, doing automated ETL with DLT in either batch or streaming. And then since once you've got all of the data in, now you need to do all of those operations on it, and that requires orchestration. And this is where Databricks Workflows comes in. This gives you reliable orchestration for data analytics and AI that works across the entire platform. Let me dive into both of these tools. First, let's talk about ETL. Why are we doing ETL? Well, it's basically a fact of life that all data starts off messy. And so you need to take this messy data, you need to filter it, clean it, augment it, and then you need to build business level aggregates that actually answer questions. And that enables all of this downstream stuff. But this picture here that I'm showing is really quite simple compared to what it looks like in real life. A real data architecture often has tens to hundreds of tables with complex interdependencies between them. And what you often find is you end up spending a lot of your time on managing this brittle infrastructure. You have a problem for ETL, so you bring in Amazon Glue in order to do that. But then you need to understand exactly how many rows are being processed to make sure nothing's getting dropped, so you bring in Datadog. You want to make sure you're getting the best out of your machine, so you bring in some low-level metrics from Amazon CloudWatch. You need to orchestrate all of these dependencies, so you have to set up your own Airflow cluster. And then after that, you need to ingest some data from another data source, and so you end up bringing in Azure Data Factory. And then I need to run some reports and SQL queries, and so I use Uzi because this old legacy team is doing it. And then finally, we can pull in another tool like Azure Synapse. What you see is this tooling ends up dominating all of your time. And this is why we created Delta Live Tables. Delta Live Tables makes it dead simple to build reliable data pipelines. And in fact, these few lines of SQL are actually a full end-to-end production pipeline. Let me walk through it really quickly. First, we see this create streaming table where we're actually doing ingestion of raw data. But the simplicity of this SQL is actually kind of hiding a lot of what's actually happening under the covers. So under the covers, we're taking this directory of JSON data called raw data. We're automatically inferring the schema to understand what that data looks like. Cloud Files also allows you to automatically tune how you're going to handle evolution. If new columns appear or columns disappear, or they change data types, all configurable by Cloud Files. The other really nice thing that it's handling is it's handling ingesting this data exactly once at any scale. So we'll integrate directly with these underlying cloud storage systems to make sure that we're getting actual push notifications. So even if there's tens of files or tens of millions of files, it's going to work the same way. Once the data is ingested, now we can use materialized views to transform and clean it up. And the nice thing here is you can see we say select from live.raw data. That's automatically creating a dependency between these two tables, and the system will automatically orchestrate how data flows between them. What this allows you to do is dramatically accelerate your ETL development. You can write code in SQL or Python, and DLT automatically handles the orchestration of the DAG and all of these complex cloud problems like handling retries and changing schemas. We automatically take care of the infrastructure for you. You don't really need to worry about exactly what type of cluster and exactly what type of instance. We have automatic recovery, we have automatic auto scaling, and we automatically optimize the performance of how this pipeline is going to operate. We have built-in tools for ensuring high data quality. So we can automatically basically allow you to specify these declarative expectations about what good quality data means for you, and the system will automatically monitor and enforce these rules. And then finally, as you can see in this example, we unify batch and streaming into one simple language. So you can have the simplicity of SQL while having the freshness of streaming all in one single API. And a key part of the DLT story is end-to-end observability and monitoring. So every part of how your pipelines operates is actually captured in the system called the event log. And what that means is you can now create dashboards that tell you not only how much data is being processed, but also kind of low-level details like exactly what the quality is and if there have been any data quality problems over time so that you can find them and proactively fix them. And now that we've got all of the data in, now it's time to orchestrate all of that analytics and AI that you can do on top of it. And the story for that is Databricks Workflows. Databricks Workflows allows you to orchestrate anything, anywhere. You can use it to run old school Spark jobs wrapped up as jars, Databricks notebooks, orchestrate Delta Live tables, to train models, to run Python scripts, or even use outside tools like dbt. The nice thing about Databricks Workflows is it has a simple workflow authoring experience. All you need is a web browser, and you can log into our UI to create these DAGs and ML workflows. It's deeply integrated into our platform, so you have centralized monitoring and centralized observability. And it's fully managed. It's incredibly important that your production workloads always run on time, no matter what's going on in the cloud. And Databricks Workflows takes care of that. And we have proven reliability from 10 years of running these critical workloads for our customers. Let's walk through what an example workflow can look like. So you often start by ingesting data and transforming it using autoloader and DLT. Then you can do some more filtering and quality assurance, again, using DLT, SQL, or Python. Then you can integrate with tools like MLflow, where you can actually do things like feature extraction. And finally, we can save those features and train a machine learning model that will allow us to predict what's going to happen in the future. And one of the cool things about the data lakehouse is it's not just about Databricks. There's an entire ecosystem of partners for doing everything from ingestion to data pipelines to governance, and then all of the tools on top for doing BI, dashboarding, machine learning, and data science. And we've had over 7,000 customers see success with this over the years. I want to dive in on just one of those customers, where we're talking about streaming an ETL with Shell. The problem here was basically predictive maintenance and analytics. So they have all of these big turbines around the world, and they're producing tons and tons of sensor data on how every individual component within that large complex system are operating. And one of their key problems here is they want to understand and predict when things are going to break, so they make sure they have the right parts and the right personnel and minimize the downtime caused by that outage. And using DLT, they were basically able to collect all of this data, multi-trillions of records, and continually improve their ability to do that analytics. And what that means is now they have hundreds of engineers collaborating on these different use cases, saving them millions of dollars in repair costs. And we have similar stories with Databricks Workflows. In this case, we're talking about YIPIT data, where they collect different data from hundreds of websites around the world. In the past, they had a lot of problem with siloed teams that were unable to kind of scale their legacy data technology. They were spending all of this time managing their own Airflow cluster rather than actually spending the time getting insights from their data. And so when they migrated from Airflow to Databricks workflows, they had a single unified platform that allowed them to manage the entire lifecycle of doing data analytics. And the end result here was they lowered their costs by up to 60%, and they also reduced the processing time by 90%. So that means they're getting faster answers, significantly cheaper. And so to summarize, we believe the best data engineering platform is a lakehouse. It gives you reliable data for analytics and AI by giving you simple batch and streaming data ingestion with Delta Live tables, reliable orchestration for all the things you do with Databricks workflows, and it's built on top of a foundation of reliability, performance, and governance that you get from Delta Lake, Photon, and Unity Catalog. Thank you.
Thank you, Michael, for that great introduction to the Databricks Lakehouse and data engineering on the Lakehouse. We'll now hear a little bit more about DLT and workflows in 2 deep dive sessions from Ray Zhu and Roland Faustlin, both staff product managers at Databricks. We'll start with you, Ray. Take it away.
All right, thanks for having me here. I'm going to spend the next few minutes to give you guys a little bit of an overview and also a deeper dive into Delta Live Table, or DLT. DLT is the first ETL framework that uses a simple declarative approach for building and running reliable data pipelines at scale and without any infrastructure management. With DLT, data analysts and data engineers can spend less time on ETL tooling and focus on getting value out of their data. Now, I want to highlight a few of the key DLT capabilities. First, DLT allows you to develop ETL pipelines in a declarative manner, where you define the what as opposed to the how. This approach is much faster and less error-prone during the pipeline development phase. Next, DLT manages your ETL infrastructure, like scaling the compute, recovering from failures, and optimizing table storage performance for you. And third, bad data will occur inevitably from the data source, which eventually impacts your analytics and machine learning workloads downstream. DLT has built-in data quality capability to prevent any bad data from flowing into your production tables and applications. And finally, as more and more data pipelines moving towards streaming for more real-time results, DLT is built with both streaming and batch support from the get-go, and all through a unified API. This is a quick diagram of DLT in the context of the broader Lakehouse platform. DLT is the default and best-in-class ETL product sitting on top of the Delta Lake and governed by the Unity Catalog product. The highly performant Photon engine is natively supported and built into DLT for pipeline execution. DLT handles end-to-end ETL from data ingestion to transformation, and again with support for both batch and streaming. Once you get your clean data in the production Delta tables, you can run a variety of downstream workloads like business intelligence, interactive analytics, machine learning, and operational applications, all through the Databricks Lakehouse platform. Now let's take a look at continuous data ingestion, which is typically step 0 of any data workloads. DLT supports continuous data ingestion from a variety of sources like cloud storage systems, message buses, and DBFS. When it comes to cloud storage, which is where the most of the data is stored these days, DLT supports a number of file formats like JSON, CSV, Avro, and Parquet. DLT also supports automatic schema inference, evolution, rescue data column through a feature called autoloader. In addition to data ingestion, you often need to perform transformations and aggregations on your data before they're ready for downstream consumptions. And an ETL pipeline in the real world could get fairly complicated with lots of dependent steps. These pipelines are hard to develop and even more difficult to maintain when you consider scenarios like failures, reruns, and backfills. DLT lets you define ETL pipelines, whether it's simple or complex, in a declarative manner. What this means is that you tell DLT the intent of how you want your data to look like, and DLT generates the step-by-step ETL pipelines for you. And there are a few advantages of this approach. Number one, it's much less error-prone during a development phase because DLT will check for and generate all dependencies for you. And number two, because DLT generates the ETL pipeline, the engine has inherent knowledge about the data flow. which allows us to deliver valuable features like end-to-end data lineage, automatic failure handling, and backfilling. Change data capture, which has increasingly become a popular workload. Apart from capturing change data from the source, a critical capability for this workload is to insert, update, and delete changes into the target Delta table. And before DLT, we provided the merge into feature in the Databricks runtime for the CDC workload, which had a set of limitations and complexities like auto handler. With DLT, we now provide an enhanced version called apply changes into. This new CDC feature allows you to specify primary key of your change data and the conditions for triggering insert, update, or delete actions. Apply changes into handles out of the order data for you automatically and also supports partial updates for source systems that only produce partial change data. And finally, apply changes into also supports schema evolution as the source data schema changes. Next, data quality, which is among the most important aspects of any data platform and remains a big problem for most data teams. DLT provides a feature called expectation to manage data quality out of the box. You can specify the expectations for your data, such as the value of the data should not be null, as well as what DLT should do when certain data violates this expectation. And some possible violation handling actions include fail the entire pipeline, drop the bad data, alert the users, or in the very near future, you can quarantine the violating data for reprocessing afterwards. And all the data quality related metrics are logged into DLT's event log so that you can query and visualize the observability data for additional insights, which leads me to the next topic, observability with the event log feature. So in addition to the data quality related metrics, DLT also logs other pipeline observability metrics like data lineage, compute scaling events, pipeline execution time, data volume, etc. in a place what we call DLT event log, which itself is also a Delta table. And that means you can use Databricks products like DB-SQL or Notebook to query, analyze, visualize, and even set alerts on these observability data stored in the DLT event log. Data platform is increasingly used in mission-critical applications and has an increasing impact on businesses when data is not available, delayed, or being not accurate. We believe that software engineering best practices like environment separation, testing, documentation, and parameterization are equally important for delivering highly available and reliable data platforms. And this is why we built software engineering best practices into DLT by default. DLT supports the separation of development and production environments, as well as testing and documentation capabilities, so that you can have the confidence to deploy any pipeline into your production environment. In addition, DLT also allows you to parameterize your ETL pipelines, which allows you to do things like testing your dev pipeline on a smaller data set and deploy to production on a much larger data set. It also allows you to separate long path and other variables from your pipeline code and apply the same transformation logic to different data sources. ETL pipeline operations, and that's a big deal. Many data teams today spends 20% of their time on pipeline development and 80% on operations and maintenance. For large ETL pipelines, rerun after failure could get fairly complicated when you consider dependencies and duplicates. Next, maintenance like vacuuming and other optimizations need to be performed on your tables in order to achieve good downstream query performance. And lastly, data volume almost always changes, and infrastructure failure like compute or networking failure almost always happen over a long enough period of time, which means you also need to carry a pager and spend effort scaling and managing your infrastructure. Now with DLT, we handle all of the above operational work for you so that you don't have to. Our goal is that once you set up your ETL pipelines in DLT, it keeps running reliably forever until you stop it. And finally, I want to cover orchestration with our workflow product. Data pipeline is almost always a part of an end-to-end workflow. For example, once your ETL pipelines are executed successfully, you might want to send out an email notification, or maybe update a dashboard in your BI tool, or maybe trigger an update to your machine learning model with the new data. Databricks Workflow is the fully managed orchestration product for the Lakehouse platform. It's multi-cloud and allows you to orchestrate DOT pipelines, as well as any arbitrary tasks to complete an end-to-end workflow.